Hello guys, my name is Prince and this is Smart Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are on the topic probability. In the previous video, we considered the multiplication law of probability. In this video, we are going to focus on the addition law of probability. The addition law of probability. If A and B are two events of the same experiment, then the probability of A or B occurring is given by probability of A union B. So if you have event A and event B and they are the same experiment, the probability that event A or event B will occur is given as a probability of A union B. So what this means is that we have event A and event B. The probability that event A or event B will occur is given as probability of A union B. The addition law of probability says that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So if we have two events, event A and event B, the probability that event A or event B will occur, which is given as probability of A union B, is given as probability of A plus probability of B minus probability of A intersection B. This is the addition law of probability. We have learnt about mutually exclusive events. We know that for mutually exclusive events, probability of A intersection B is equal to 0 because A and B cannot occur together. So the probability that A and B, probability of having A and B, which is the same as probability of A intersection B, is equal to 0. So if A and B are mutually exclusive events, then the addition law of probability becomes probability of A plus probability of B. This means that if A and B are mutually exclusive events, then the probability that A or B will occur, which is also written as probability of A union B, is given as probability of A plus probability of B. So this is the addition law of probability. If you have two events, event A and event B, probability that event A or event B will occur is given as probability of A plus probability of B minus probability of A intersection B. But if A and B are mutually exclusive events, we know that probability of A intersection B, which is probability of A and B occurring together, is equal to 0. So the addition law of probability becomes probability of A union B, which is the same as probability of A or B, is equal to probability of A plus probability of B, because probability of A intersection B becomes 0. Let's solve a question with this. Given that probability of x is equal to 0.21, probability of y is equal to 0.51, and probability of x intersection y is equal to 0.31, find probability of x union y. We have been told that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. This means that probability of x union y is equal to probability of x plus probability of y minus probability of x intersection y. We have all these here, so all that we need to do is to substitute in the values. So we are going to have 0.21 plus 0.51 minus 0.31, and this will give us 0.41. Let's try another example. If two events x and y are mutually exclusive and Probability of x is equal to 1 divided by 3. Probability of y is equal to 2 divided by 5. Find I, probability of x intersection y. II, probability of x union y. Now we are being told that x and y are mutually exclusive. If x and y are mutually exclusive, we know that probability of x intersection y is equal to 0, because for mutually exclusive events, they cannot occur together. So probability of x and y occurring together, which is the same as probability of x intersection y, is equal to 0. We also know that probability of x union y is equal to probability of x plus probability of y minus probability of x intersection y. But for mutual exclusive events, probability of x intersection y is equal to 0. So this side will be off. This means that probability of x union y is equal to probability of x plus probability of y. We have probability of x here, we have probability of y here. So we just substitute them in here. We have 1 divided by 3 plus 2 divided by 5. And this is going to give us 11 divided by 15. So let's go over what we've learned so far. We have learned that if A and B are two events of the same experiment, then the probability that A or B will occur, which is written as probability of A union B, is giving us probability of A plus probability of B minus probability of A intersection B. But if A and B are mutual exclusive events, then the probability that A or B will occur, which is written as probability of A union B, is giving us probability of A plus probability of B. This is the addition law of probability. In the previous video, we considered the multiplication law of probability. We learned that if we have two events A and B, probability that A and B will occur is giving us probability of A times probability of B. So when we have the word "and", we are going to multiply the two probabilities. When we have "and" here, we are going to multiply the two probabilities. So "and" means that we are going to multiply. We have learned in this video that when you have two events A and B, probability that A or B will occur together, if the two events are mutually exclusive events, is giving us probability of A plus probability of B. So when you have the word "or", you are going to add. Now take note of this very, very well. We are going to apply it as we solve questions on probability. When we see "and", we are going to multiply. When we see "or", we are going to add. Thank you for watching this video. In the next video, we are going to apply what we've learned about the addition and multiplication law of probability to solve practical problems. Bye-bye.